Hey everyone, wanted to let you know that there might be a chance to see the Northern Lights. Zach just walked in, like right now. I'm waiting for some laundry to be done at the laundromat, sit and spin. So I was like, you know what? I'll just pop in here real quick while
Why
I'm
not?
waiting, and about to go hit the gym as well.
Oh, just got back.
Oh man, my legs are sore because I hit that
Nice.
yesterday. But the big question now is, will we see the Northern Lights tonight? Last night into this morning, the coronal mass ejection already hit, as Joel alluded to, and it was a pretty powerful CME, and it came in a lot earlier than expected. So people are saying the answer is no. Well, it's possible. It might not be exactly, let's just say, as clear cut as it was this morning, because the Northern Lights were seen this morning. So let's get right to it. And first of all, show you what happened yesterday and last night into this morning. And so this is what it looks like with spaceweather.com. If you are a big follower of this, I'll explain what it is. And let's just say I'll go through this kind of quick because I'm not going to spend all day on this. But first of all, this is what happened on the evening of May 30th, our time, right around 7:05. So May 30th, which was a couple of days ago, at 7:05 in the evening, the sun erupted with what's called a solar flare. Now, this was nearly an X-class solar flare. Didn't quite reach that level, but it was 8.2. Now, once you get to basically X class is like the strongest class you could possibly have in terms of a solar flare. So that's the strongest that you can get. But in this case, this was an 8.2 solar flare, and it was a long-lasting explosion for 3 hours. And as you can see, it wasn't quite X-class, but the most important thing that it did is it released what's called a coronal mass ejection. Now, this is an area of plasma in the sun, charged particles that shoot out of the sun. And when the explosion happens to be Earth-directed, well, then that comes our area, comes to our planet. Now, this is called a full halo CME, where coronal mass ejection, when it's a full halo CME, it's a just kind of like a perspective thing. It's coming right at the Earth, so it looks like it's spreading around the sun. But since it comes at the Earth, just like if I were to do this, it comes from all different directions. So it's Earth directed. Whereas if it's going this way, you might only see it leave. But this is a full halo CME that took place. So now, what was the result of this morning? Well, that actually got to a G4 geomagnetic storm. And you'll see here that the auroras were seen as far south as the Gulf of Mexico. That was early this morning. So scientists and astronomers, they thought that this CME would hit later on this afternoon, which would lead to the Northern Lights tonight. But in fact, it actually hit this morning, and I'll show you. But here's some of the photos. Like, we'll take a look here. Here's from California, some images. I love this site, so you can look at a lot. Here's Colorado. You can see the aurora on the off in the distance, and obviously Missouri, just a state north of us. Let's see what it looked like from Missouri. So let's see. This is in the early morning hours, so about 3 a.m. So it was a surprise, but that's why I tweeted and I put it out. But it may not be done completely, and I'll get to why, because we still have more of the solar wind that's taken place. So let me show you before we get into the forecast. I'm going to show you what a coronal mass ejection does and why we have the Northern Lights. But this is like some of the graphs. So you'll notice right here that we had a little bit of like these minor solar flares, and then this X class, or nearly X class, the M8.2 came in and caused that coronal mass ejection to hit the Earth. And you could see exactly when it hit. Man, it hit this morning, and that just went nuts in terms of not only the BZ is what you look for. The BZ, this red area, that has to be pretty low, below zero in the negative values. And it was, as you can see, it was up to a -20, which is pretty strong. And then it kind of bounced around and reverberated. So it wasn't a long-lasting solar storm, but here's the deal. You'll see how this was all positive right here throughout the day, but now it's starting to drop off. So it comes in waves. It's like ebbs and flows, if you will. If we scroll down here, you'll notice the speed of the solar flare was the speed of the coronal mass ejection was, or the solar wind, should I say, was around 700. And then as soon as that hit, almost like, think about it this way: you step on the gas, your car is going to go a lot faster. You're going to accelerate. That's exactly what happened here. Notice though, we still have a solar wind that's exceeding 900. That's pretty fast. So there still could be a geomagnetic storm. Now, while it might not be as strong as this morning, there's still a possibility. And then the density on top of that, look at how all that increased too, the temperature and the density. So that was a pretty powerful solar flare. I got some other charts too to show you. This is over the last 12 hours. And so here you'll see in the morning hours, this is when it hit. Look at how that hit and then just increased dramatically. If we scroll down and we look at some of the other stuff, this is the BT, basically the amount of charge, the planetary charge. And then we go scroll down here and you can see the BZ. Now, if we go back to 24 hours and we'll extend this out, this is where that solar flare hit and the coronal mass ejection with all that charged plasma. And so that kind of bounced around, but you'll still see it's still kind of going up and down. So if we look at the Space Weather Prediction Center and see what they've got in terms of their forecast, I'll show you what they've got. So they have a G2 right now. It was a G4 earlier. They still say, though, a G4 might be the forecast for already, but we still have a G4 predicted for June 2nd. So this is going to continue to reverberate, and it's not necessarily done. Now, as we get back to the details, I want to show you kind of some graphics on what the solar wind is. And if you've seen the movie Knowing, you know that like people melt. That's not what happens. That's Hollywood for you. But this is what the aurora borealis essentially is. That charged plasma that gets shot out of the sun when the sun explodes, a sunspot, essentially a magnetic field that's all twisted up, and then it releases like that. As that happens, those charged particles, those charged protons and electrons, plasma from the sun, emitted from the sun, starts racing towards the Earth. Well, we have the magnetic field around the Earth, magnetosphere, and what that does is that deflects a lot of that energy. But sometimes, if the charge in the solar, in that solar wind, and not only that, but in that coronal mass ejection, if it's negative, if it's negatively charged, or should I say southward pointing, that can interact with the Earth's magnetic field. And then those can get to the poles. And then when that happens, you start getting excitement where electrons collide with various molecules in the atmosphere. So here's the reason for the different colors. I thought this is kind of cool, but the resulting collisions and the excitation of the particles, essentially, and they get charged, and you have basic varying colors from the height and the type of molecules hit. So red auroras, which is typically what we see from Arkansas with the northern lights, because they are really high above the Earth's surface. Those are essentially oxygen molecules, and that's about 200 kilometers above. So when you're looking off on the horizon, you're actually seeing pretty high up in the atmosphere. Blue auroras are nitrogen molecules. Green auroras, which can be seen, are oxygen molecules, but that's only about 10 to 20 or 100 to 200 kilometers up. So you still have oxygen molecules, but that's a little bit lower in the atmosphere. And then you have nitrogen molecules below 100 kilometers. That creates essentially nitrogen molecules and the pink auroras. So that's the reason for the different auroras. Kind of cool, but it's a solar wind. And then that, if it has charged plasma, can create a crack in the Earth's magnetic field. That charge will link. The protons and electrons will get excited, and that's why they glow. And that's what the northern lights is. It's not really a threat directly to you, but it does affect GPS communication, does affect satellites, does affect other things, and also HF radio too. So high frequency radios. There's radio blackouts. There's all sorts of stuff that can happen And that was a pretty big solar flare that caused that. Now, I'm not by any means an expert on this. I've learned a lot. I've done a lot of self teaching. I've done some classes. So I'm not like, let's just say I'm not an expert on space weather and solar storms, but I'm just educating you as much as I can. Now, the aurora forecast for the next 3 days, it's all about the K index. The K index is essentially how much the Earth's magnetic field is going to interact with that coronal mass ejection and the solar wind. So today, this morning, we already had a KP index of 8. And I could go back to this to show you. So this was what we had earlier, was the KP index of 8. So you can see right here, this is in the morning hours when that coronal mass ejection initially hit. And when it did, man, it created a shock wave. Then it jumped down to 7.3. Then it went back up to a 7.67. And now it's currently at a 5. If it remains at a 5, then that's not going to be a big deal. And I know that you hear severe solar storm. What exactly does that mean? Well, I'll show you. So severe solar storm, it creates possible widespread voltage control problems, and some protective systems will mistakenly trip out of key assets from the grid. Spacecraft operations, so surface charging, tracking problems, and other systems, pipeline currents, HF, like I said, radio propagation, sporadic, satellite navigation degraded for hours, low frequency radio navigation disrupted, and this is where the aurora is seen. So it's not really a whole lot of like impacts to you, your skin, burning, stuff like that. But you'll notice here, G4s only happen about 100 per cycle. A solar cycle is 11 years, and we are currently in solar cycle 25, and it's getting close to the peak. So if we look here, we're currently now in a G3. So we still have that potential for a reverberation of the aurora. And you can see here, this is a look at the aurora forecast. And right now, it's not showing up. But then again, if we go to this and actually play it in real time, you'll be able to see kind of how it evolved. So let's go ahead and do that. I'll show you when this auroral activity really cranked up. So let me go to it real fast. Okay. So yeah, we're expected to. This is what's interesting about this is that right now. So this is the auroral forecast. Now keep in mind, a forecast is just as good as a weather forecast. It can be wrong, but you'll see here, 12-15 hours on June 1st. So this already has a KP index of 8, and then it kind of see how it drops down to a 7, and then it bumps back up to an 8. So this is actually June 2nd, 0 hours to 3 hours, which is essentially tonight, showing that we still could hit a KP index of 8. And then if we go here, we'll look at the auroral activity, the real-time auroral activity, the auroral oval. All right, and then this is what's happening right now. So this is and if we play this, let's see if you get to see how it evolved. So this is what happened. Let's see here. Let me go back. Yeah, this is when that coronal mass ejection hit, and look at how the solar power just really started to crank up. So that's why the auroras were seen. Here's what I got to do. I got to find that animation real fast, and it might not be showing because it's not full screen. So let me go to stand by. I got to show you how quickly things can change. Here we go. This is what I'm looking for right here. Yep. Okay. Let me bring this up. So this is the auroral forecast, and watch how last night we were talking about how there could be the northern lights. You can see the time right here, but watch how this just goes nuts where you have the reds. And so those reds is when you have the geomagnetic storm. So it's kind of like severe weather, honestly, where it can ramp up and develop really, really fast. So that's why you need to be watching it tonight. No, it cannot, Brendan. And we just went into that. It's not going to cause the end of the world. That's Hollywood for you. But this is what the auroral forecast looks like. Notice the time. This is from last night into this morning. So 4Z is 11 o'clock last night. And then once it hits midnight and gets into June 1st, this just goes nuts. And the reason why is because that coronal mass ejection hit just a little bit early, and a lot earlier than what astronomers and scientists and solar scientists and all that stuff thought. So that's why you're seeing that. So going back to now, the question is, and this is where I could come in. This is where I am an expert, just enough to know that I still need to know more, and that's about the weather. So this is what we're calling for a forecast. I still think we could have a KP index on Monday of 7, maybe not an 8, because we already had the initial shock. That's correct. 0Z is 7 p.m. the night before. So there's a look at Tuesday is not going to happen. But that sunspot that's still out there, just to let you know, it's sunspot 4100. It's still Earth directed, as you can see, and this still could launch another big X-class solar flare, which would be Earth directed, and it would also cause another potential for the northern lights. So you can see right here that sunspot 4100 poses a continued threat for X-class solar flares. And so if we go into this, here's a look at that M8.2, and then that did not take long to reach us. So it was less than a day. That's pretty fast, which is why it's tough to know exactly how fast those coronal mass ejections are going. So there's the forecast. And now let's take a look at the weather. What's the weather going to do? Well, Zach, you're looking at storms. We got a very active week, and I'll let Zach cover that. But I will say that the smoke isn't as bad as it was yesterday. But we did have a lot of thunderstorms this morning, which prevented the viewing for us for the northern lights. That's why not a whole lot of people saw it. Even people that are up and at them early in the morning, 2, 3 o'clock in the morning, we had that round of storms that came through, and all that cloud cover prevented viewing. So that's why you don't see any pictures from Arkansas. But they did see it from Missouri because the storms are already south of there. Here's a look at the big picture. This would be a great night if it happens, because it is clear all the way up to Canada. So the potential for seeing the northern lights, if we get to a KP index or a K index of 8, that's going to be something that is going to be possible. Now, what about that Canadian wildfire smoke? You can still see that over the Great Lakes. It's not as bad here. It was pretty thick yesterday, and I know Zach was talking about that. Here is a look at the current smoke, and you can see it's pretty heavy, but it's kind of heavy to our north. And honestly, I don't really know what the northern lights and smoke will do. Like, because I know sunsets look a lot prettier and the colors are really awesome in smoke, but there's going to be more scattering of the light. That doesn't necessarily block it out. Maybe it makes it a little less clear, but maybe it also enhances the colors. We'll see. But there's a look at all of that. Now, there's also the dust, too, that's coming from, and I'll let Zach cover that. But there's all that dust, Saharan dust that's coming from west coast of Africa. And that's going to make it into early next week. That's coming from the south. But here's a look at that smoke that's happening. It's all from those Canadian wildfires. And the way our jet stream is, we got this big ridge of high pressure for now, and that's bringing that smoke south. So that's why we've had that smoke. So here's the surface smoke forecast. It's a little thicker to the north, but still we've got the low end of that smoke forecast. And then you can see by the as we get into the week, now you're starting to see smoke coming from the south. It's really not smoke, it's dust, but you get the idea. We've got that as well. So this is what you need to know. The Northern Lights possible over the next couple of nights. I don't think couple of nights. I think tonight that's one shot, and I really honestly think the chance I would say is only like 30%. So it's not a great chance. It already happened this morning. The timing of the CME arrival is a forecast, so we already know the coronal mass ejection hit. There was no other um, there is not like a cannibal CME or anything like that, or no other coronal mass ejections that I know of that are coming. Favorable viewing with a clear sky, so we do have that. That's good. And stay tuned for more updates because Zach could be doing the weather tonight. And next thing you know, we're under a KP index and the Earth's magnetic field goes crazy. So, it right now it's not going to be possible anywhere, but it's got to change, and that could. So this is what you need to watch. Just to let you know, this is what you need to watch. So the best thing to do is to watch the KP index. So here's what I'm going to do. I'm going to send you this. Let's send you this link here. This is better. I'm going to post this link on here. So this is the website that you want to go to. And what this does is it will show you if that BZ is getting really negative. If that BZ, the red line, is starting to go very negative, and I'll zoom in on this so you can see. That's what you want to look for is when it goes real negative. Right now it's positive, so nothing's going to happen. But if that BZ is negative, meaning we got southward magnetic field, southward pointing magnetic field that's interacting with the Earth's magnetosphere, that will cause the northern lights. And so if we go back here, whoops, go back to this, unzoom, go to that link. This is when it really went nuts. So I'll zoom in on this and I'll show you. So this is when that, oh, what happened there? Let me refresh that. Right here, I'm going to zoom in this time. Nope. Guess not. Let me go back here. I'm going to go to series. I'm going to change this. I like this here when you do options. I'm going to do line, a hybrid with the line. So you can see with the line as well on there. All right. And then we're going to go to 1 day, 6 hours. So 6 hours, you can still see it's kind of going negative. Go to 1 day. I don't know why it's not zooming in for me. There we go. And then it just freaks out after that. Not sure why it does that. Well, anyways, this is when it went really negative, and this is where that solar storm took place. But you can kind of see how it's still bouncing up and down. It's still very much unstable. And look, the solar wind is still increasing in speed. So there's still a chance that if there's any type of southward pointing magnetic field in that solar wind, that things can happen. Oh, yeah, you can't see it. That's right. Okay. So this is let me go over all this because it didn't work anyways. So this is what you're looking for, this BZ. This BZ right here is the red line. Red line has to be really negative. Right here, it did get really negative. It got down to minus 20 BZ. And that minus 20 BZ is where you have the strong solar storm, a G4. But then you see right here that it's kind of reverberated a little bit, but it still is unstable. And so it's kind of bouncing around. All I've been doing before is trying to zoom in and it doesn't show. And so don't worry about that. The solar wind is still increasing in speed. You can see how it really ramped up. So anytime that solar wind is really strong, you can still see potentially the northern lights. And then right here, the density too is important. And so it's still a little unstable. But and then you also want to look at the KP index too. So if you have any type of alerts for the KP index, you go right here. We're currently at a 5. This is a 3-hour average, by the way. And so this was in the morning, late morning, afternoon, right now. That could bounce back up. Zach will be watching that. We'll let you know if that bounces up. And if it does, and we get to a G4, that's when you'll want to be looking out. So if we do start seeing the northern lights, then I will let you know. Now, that link has to work. It's definitely a link. Space Weather Prediction Center. It has to work. Yeah, download the Aurora app. Exactly. There's many different apps. There's many different things that you can look at and keep up with. So, all right, guys. Well, that's it for the Northern Lights explanation, and we'll continue to let you know more. But I'm going to shut this down. You have a great rest, Josh Rugger. He's at baseball games. Be watching for that BZ to go negative. Right now, it's not looking favorable to see the northern lights. It was kind of a surprise show in the early morning hours, but you never know. Things could ramp up again, so we'll see. Okay, guys, thanks for watching. Take care. God bless. Zach will have the latest weather forecast, which looks pretty active, including severe weather potential Tuesday. And Zach and I and Peyton are going to be doing some golfing tomorrow.
Let's go.
And then after that, getting some steaks tomorrow night.
Yes, sir.
Yeah, yeah. All right. Well, take care, guys.